Okay, so in this lesson we're going to solve higher order polynomial inequalities. Now before we begin looking at problems that we consider higher order polynomial inequalities, let's remind ourselves about the previous lesson. So in the previous lesson you solved quadratic inequalities. And so when you solve these quadratic inequalities, in every situation, something like number 3 as well, we used this process. So we're going to use that same process in this new lesson on higher order polynomial inequalities. So let's go ahead and look at some examples dealing with this. And again, we're going to use this process just like we did when we solved those quadratic inequalities. So let's do number 1. So number 1, let's suppose in number 1 that we had this problem. So the directions will say something like solve each inequality. And probably it will say solve each inequality algebraically. Okay, so number 1, we have x minus 3 times x plus 2 times x plus 5 is greater than 0. So I have this inequality. I know it's an inequality because of this inequality symbol. And I know that if I were to multiply these three binomials out, you're not going to do that, but if you were, you would have a higher order polynomial. For example, x times x times x is x cubed. So this would be a cubic polynomial inequality. All right, but regardless of whether it's cubic or x to the 4th power or whatever power it may be, whatever higher order it may be, do know that you have to follow those steps. So in step number 1, we have to make sure that it's in standard form. So we have to have 0 on that other side. And I do. I have 0 on that other side. Then the second thing I do is that if this polynomial is not factored, I factor it. Well, in this case, you'll notice that you are listed the factors. So you have 3 factors here, x minus 3, x plus 2, x plus 5. So it's already been factored. And then now we're going to identify the zeros. So remember how to identify the zeros. So our zeros are, and remember another name for zeros that you'll sometimes hear are critical numbers. Sometimes you'll see the words boundary points instead. So to find the zeros, once it's in factored form, and this is already in factored form, you set each factor equal to 0. That's how you find your zeros. So we're going to say x minus 3 equals 0, x plus 2 equals 0, x plus 5 equals 0. And so your zeros are, solving for x, you get 3. Over here, it is negative 2. And then over here, it is negative 5. So those are your 3 zeros. So there are 3 zeros here. And then once you find the 3 zeros, remember the next step is to put those zeros on the number line and make sure they're in increasing order. And just as in the previous lesson when we talked about quadratic inequalities, those zeros divide your number line into intervals. So I'm going to put those zeros on the number line. And let's put them in numerical order. So negative 5 is going to be listed first, then negative 2, and then positive 3. And I guess I should have had a few more. Let me go ahead and space it out a little bit better. So negative 5, negative 2, positive 3. Okay. All right. Now, once you put the number line, remember the whole point is to determine which of these intervals, and notice that those 3 zeros divided the number line into 4 intervals. This interval, you have this interval, you have this interval, and you have this interval. And I'm going to say those intervals. You're going from negative infinity to negative 5. That's an interval. You're going from negative 5 to negative 2. That's another interval. You're going from negative 2 to 3. That's your third interval. And then the fourth interval, as you go from left to right, is 3 to infinity. So those 3 zeros divided the number line into, in this case, 4 intervals. Now, you have to determine which of those intervals will be solutions to this original inequality. And to do that, just like we did in the previous lesson on quadratic inequalities, to do that, you are going to use test points. Remember those test points? All right. So I've got to pick 4 test points here, one from each interval. It is always easiest to use a test point that's an integer. So in the interval -5, negative infinity to -5, what test point do you want to use? It does not matter what you use as long as it's in this interval. So I'm just going to go ahead and pick the test point -7. I'm going to put the test point in parentheses. In this interval, and remember it's always easiest to use an integer. You can use a decimal, you can use a fraction that's in this interval, but it's always easiest to use an integer. So in this interval, there's not that many integers left. You have -4 and you have -3, and that's it. Just 2 integers. So let's go ahead and choose -3. In this interval, if you can use 0, then use 0. It's always the easiest. I'm going to use 0 here. And then in the interval from 3 to infinity, let's use 5. All right, so those are my 4 test points. For each of those test points, I'm going to go back and substitute it into this left-hand side here. All right, now before I go on, let me also indicate this. The zeros here, -5, -2, and 3, remember that those are zeros, right? Those are zeros, which means that if you substitute -5 into this inequality, you're going to get a product of 0. In fact, you do, because look, -5 plus 5 is 0, and 0 times all of this is 0. So I'm going to put 0 here to indicate that that's a 0. Same thing here, -2. -2 plus 2 is 0, so all of this product is 0, regardless of what's on the other factors. And the same thing for 3. So automatically we'll put zeros there to indicate those are zeros. All right, now let's pick a test point, -7. Wherever you see the variable x, you're going to substitute -7. And it's always easiest, in this case it's already factored, it's always easiest though to go to your factored part. So look, I'm going to write it out. -7 minus 3 times -7 plus 2 times -7 plus 5. So wherever we saw the variable x, let's substitute -7. Now all you got to do though is determine whether that factor is negative or positive. That's all you have to do. -7 and -3 is a negative number, so that's negative. It's actually -10. -7 plus 2 is a negative number, and -7 plus 5 is a negative number. And then ask yourself, what's a negative times a negative times a negative? Well, a negative times a negative times a negative is a negative. Now, as you go along, I want you to notice this, and also an important aspect of this process is that you want this product right here, no matter what value of x you substitute, your solutions will be the ones in which this product greater than 0 means positive. So you want this product to be positive. So when I look at this product here, when I use that test point, what that means is that if I were to choose any other number in that interval, -8, -10.2, whatever it may be, this product will always be negative. That's not what I want though. I want this product to be positive. So this interval is not going to be a solution. My solutions will not come from this interval. Let's go to the next one, -3. When x is -3, here's what I get. I get -3 minus 3 times -3 plus 2 times -3 plus 5. And so -3 to -3 is a negative number. A -3 plus 2 is also a negative number. It's actually -1. And -3 plus 5 is a positive number. That's +2. A negative times a negative times a positive is a positive. What that means is that if I pick any real number that's in this interval from -5 to -2, and I substitute in here, this product here will always be positive, and that's what I want. So my solution so far will be in this interval. I go to 0. When x is 0, I have 0 minus 3, 0 plus 2, 0 plus 5. 0 minus 3 is a negative number. It's actually negative 3. 0 plus 2 is positive. 0 plus 5 is positive. A negative times a positive times a positive is a negative. And remember, you want this to be positive, so your solutions will not come here. We go to 5. When x is 5, I have 5 minus 3. Oops, let me put it up here. 5 minus 3 times 5 plus 2 times 5 plus 5. 5 minus 3 is positive. 5 plus 2 is also positive, and 5 plus 5 is positive. A positive times a positive times a positive is a positive. And that's something I want, because I want this to be positive. It helps if you actually write out what kind of number you want this product to be. Be a little bit careful. Some students always think that they alternate. Negative, positive, negative, positive. That's not always true. So be careful. You actually do the work. All right. Okay, now, so let's talk about the solution. So once you get to that point, you're almost done. So the next step is to identify which solutions, which intervals make the inequality a true statement, and then you write your solution in interval notation. So I found out which one works, so I'm going to put that in interval notation. Now, one thing you got to remember is that on these zeros, you're either going to use parentheses or brackets. Since this is a strict inequality, there's no equal sign, you're going to use parentheses on all of those zeros. So here's how you're going to say it. So your solution, you're going to say parentheses -5 to -2, that interval. Don't forget to use the word, the symbol for union. So this is union. I'm using the word union. Union. And then the next one is what? 3 to infinity? So union 3 to infinity. Okay? And that's it. So there's your solution. So any number that's in those two intervals, any real number that's in those two intervals will be a solution to this inequality. So that was number one. It's not difficult at all. You just got to follow that process, the same process you did in the previous lesson when you solved quadratic inequalities. All right, let's look at number 2. So in number 2, you have x to the 4th minus 5x squared plus 4 is less than or equal to 0. Okay, so this time it's not factored, but I do have it in standard form. I have 0 here. It's a higher order polynomial. It's x to the 4th, and you saw several ways to do this. I'm just going to go ahead and start factoring this. See how the middle term variable is x squared? So let's go ahead and factor this. And so I get x squared times x squared is x to the 4th. And I want the product, the last to be 4. So let's do 4 and 1. And the last sign's positive, so that means the signs in the middle have to be the same as this one. So both negative. And so that should work. So when I factor this, I get this. Now, you can do one of several things. You can set each of those equal to 0, or you could factor it further. All right. What most of you are going to do probably is you're going to probably set each of those equal to 0. But you could have gone further with that, because that is still the difference of two squares. Because look, x minus 2, x plus 2, x minus 1, x plus 1. Okay, and don't forget to say less than or equal to 0. But again, as I was saying, you could have said x squared minus 4 equals 0, x squared minus 1 equals 0, and then you could use the square root property. So x squared equal 4, x squared equal 1, and then take the square root of both sides. Don't forget plus or minus, just like you did before. And so you get x to be plus or minus 2, x to be plus or minus 1. And so notice those are the same ones you would get if you set each of those factors equal to 0. So your zeros are going to be x minus 2 equals 0. So x is 2. That's this one here. Well, one of those, plus or minus. The other one is x plus 2 equals 0. So x is negative 2. Then the other one is x minus 1 equals 0, so x equal 1. And the other one is x plus 1 equals 0, so x equal negative 1. So you have 4 zeros. So again, it did not matter whether you went from here to this, or you factored further. It does not matter. Okay. Now, so there are 4 zeros. So the next step, once you find your zeros, remember, once you find your zeros, that's where you're going to put those on the number line. All right. So let's go ahead and do that. All right. So put that on the number line. Let's put them in order. So negative 2 is going to be listed first, then negative 1, then positive 1, and then 2. Now notice that those zeros, remember why they're called zeros, because when you substitute it into the original inequality, this one, let's say, you're going to get 0 on the left-hand side. All right, so I'm going to put 0 here since all those are zeros. All those are zeros. Now, one of the other things we got to also see before we go any further is that when I put those zeros on the number line, those zeros, and there are 4 of them, divide the number line into 5 intervals. 1, 2, 3, 4, 5. So it's a little bit more work to do to find the solution because there are 5 intervals here. In the previous problem, there were 4. 1, 2, 3, 4. Here there are 5. And there were 4 because there were 3 zeros. Here there are 4 zeros. Okay, now, so now we got to pick test points. And before we pick the test points, let's remind ourselves that we're looking for the intervals. We're looking for the intervals in which the values of x will make this product less than 0 or equal to 0, meaning negative or 0. Negative or 0. This time we're using 0 because there's an equal sign. Here we just said positive because there was no equal sign. Okay? All right. Now, so let's pick some test points here. Remember, when picking test points, it's always easiest to try and use a test point that's an integer. So in this interval, I'm going to use negative 4. From negative infinity to negative 2, negative 4 is in that interval. Over here, though, there is no integer that's in this interval. There's an infinite number of numbers, but there's no integers. So let's go ahead and use a decimal, let's say negative 1.5. Let's do that, negative 1.5. Over here, from negative 1 to 1, there's only one integer. What integer is that? 0. Good. There is no integer between 1 and 2. There's an infinite number of numbers, but there are no integers. So let's use 1.5 in this case. And then over here, let's say 4. All right, so from 2 to infinity, we'll use 4. Okay, so those are my test points. So now what I'm going to do is I'm going to substitute those test points into, and I'm going to use the factored part here. All right, now I'm going to say this. Remember, some of you may have gone from here to here, so you got to be a little bit careful. I'm going to show you what to do. So let's suppose that you went ahead and you factored it at this point here. So what you would then do is in place of x, substitute negative 4. Now I don't have enough room here, so I'm going to have to use another sheet of paper just to kind of help with the explanation. So test point x equal negative 4. So when x is negative 4, my test point. When x is negative 4, I'm going to go back here, right here, and where we see the variable x, I'm going to substitute negative 4. So I get negative 4 minus 2 times negative 4 plus 2 times negative 4 minus 1 times negative 4 plus 1. Remember, all you're interested in when you get to that point is determining what's the sign of each of those factors. Well, negative 4 and negative 2 is a negative number. It's actually negative 6. Negative 4 and a positive 2 is a negative 2. A negative 4 and a negative 1 is a negative 5, so that's negative. And a negative 4 and a positive 1 is negative as well. That's negative 3. But a negative times a negative times a negative times a negative is a positive. So that's positive, right? So when I use a test point negative 4, this is positive. And that's not what I want. I want this project to be negative. So my solutions will not come from this interval. Now, if you had used, just before we go into the next test point, if you had used x squared minus 4 times x squared minus 1, you're probably going to need a calculator. All right, so, and you got to be careful. So you have this. You have x, which is negative 4 squared minus 4, times, and then x squared minus 1. See, that's what you have. So you got to be careful when you don't factor all the way. So in your calculator, though, when you use your calculator, you got to make sure that when you put that negative 4, it's in parentheses. Because if you don't put it in parentheses and you say negative 4 squared, you're going to get a negative number, and that's not correct. Because negative 4 times itself is a positive 16, so be careful. So that's 16 minus 4 times 16 minus 1. And 16 minus 4 is positive, 16 minus 1 is positive, and a positive times a positive is a positive. So you see it's still positive, regardless of whether using this or the complete factorization, you still get the correct positive component. Now, let's use the test point negative 1.5. So for the test point negative 1.5, test point equal negative 1.5, that's 1.5. I'm going to go ahead and use the complete factorization here. So when I do that, let me go ahead and try and put it on this side here. When I do that, I get negative 1.5 minus 2 times negative 1.5 plus 2 times negative 1.5 minus 1 times negative 1.5 plus 1. Okay? So negative 1.5 and a negative 2 is a negative number. It's actually negative 3.5, right? Negative 1.5 plus 2 is a positive 0.5. Negative 1.5 and negative 1 is negative. And then negative 1.5 plus 1 is negative as well. So a negative times a positive times a negative times a negative is going to be a negative, right? So that's negative. So this right here is negative. So the question becomes, if I choose any number in that interval, that product will be negative. Is that let me move that out of the way. So you see less than or equal to 0. So is that something I want? The answer is yes. So that's going to be a solution. Now also note, guys, that you want it to also equal to 0. So you want that 0 to be included as well, because that equals sign. So I'm going to put bracket here to remind me that I need to include that 0. Okay? All right. And then same thing here, bracket, and then bracket for all of those zeros because of that equal sign. Okay. Now let's go to the next. Oh, and by the way, if you had used this instead, here's what you have to do, and you have to be careful. You have to say negative 1.5 squared minus 4 times negative 1.5 squared minus 1. On your calculator, you got to put negative 1.5 in parentheses. So here's what you've had to do. You've had to say in parentheses negative 1.5, close the parentheses, square it, and then say minus 4, and you get a negative 1.75. So that's a negative 1.75, so that's negative. Over here, in parentheses, negative 1.5 squared. And the reason we put in parentheses is because negative 1.5 times itself is positive. So if you enter right now, you better get positive, and you do. But I got to subtract 1, so that's positive 1.25, which is positive. So a negative times a positive is a negative, and that's what you got here. All right. So you just got to be careful. You have to be careful depending on whether you factored partially or you factored completely. So you have to be careful. If you factor completely, then it's a little bit easier to deal with. All right, so this is what this is negative. All right, now if you use 0, your next test point, so x equals 0, same thing, right? X equals 0. I'm just going to go ahead and stick with the factor completely part. So if x is 0, I'll show you what you get. If x is 0, you have 0 minus 2, 0 plus 2, 0 minus 1, 0 plus 1. 0 minus 2 is a negative number, that's negative 2. 0 plus 2 is positive. 0 minus 1 is negative. 0 plus 1 is positive. A negative times a positive times a negative times a positive is a positive. And so this is positive. So that means that any real number in that interval, will make this, any one of these, a positive product. Is that something you wanted? No, you wanted this product to be less than 0, which is negative, or equal to 0, which is 0. So you're not going to use it. Then you do 1.5. So you do that. You keep doing that same process. So at test point 1.5 now. And again, I'm going to go ahead and just use the factor part here. So if x is 1.5, we're going to get 1.5 minus 2, 1.5 plus 2, 1.5 minus 1, 1.5 plus 1. And so 1.5 minus 2 is negative. It's actually negative 0.5. 1.5 plus 2 is positive. That's 3.5. So again, if you can't do this in your head very quickly, use your calculator. 1.5 minus 1 is positive. That's positive 0.5. 1.5 plus 1 is 2.5. That's positive. So a negative times a positive times a positive times a positive is a negative. So no matter which test point I use, which real number I use that's in this interval, when I substitute into one of these expressions here, that expression, that left-hand side, will be negative. And is that something I wanted? That sure is. So one of my solutions sets will be this interval as well. And then finally we do 4. So if x is 4, you do the same thing. I'm going to go into the factor part, the factor completely part here. So I get 4 minus 2, 4 plus 2, 4 minus 1, 4 plus 1. And so when I look at those factors, 4 minus 2 is positive. 4 plus 2 is a positive number. 4 minus 1 is a positive number. 4 plus 1 is a positive number. So positive times a positive times a positive times a positive is a positive. And so in this interval from 2 to infinity, no matter what real number I use in that interval, that left-hand side will be positive. And I'm looking for intervals in which I'm going to get this to be negative. So that's not one of my solutions. So if you look at this, the only things that are checked off is this interval and this interval. So your solutions, remember there's an equal sign, so don't forget brackets. So your solutions are going to be from, make sure you read this correctly, you got to use those test points from, not test points, I mean your zeros. So negative 2 to negative 1, okay, negative 2, and I forgot to put a bracket here as well, bracket. So every time you have those zeros, you got to put bracket because of the equal sign. So bracket negative 2 to negative 1, union, and then it's this one here from 1 to 2. Union, 1 to 2. And that's it. So any real number that's in this one of these intervals is a solution to that original inequality. Okay? All right, so that was number 2. It's not that difficult at all. Fairly simple process. Just follow those same steps over and over again. All right, let's do number 3. So number 3, we have x cubed plus x squared minus 16x minus 16 is greater than or equal to 0. So I have this higher order polynomial equation. It's already in standard form, but the problem is it's not factored. Well, you saw in one of the lessons a while back that this is 4 terms, and so we could try factoring this by grouping. Remember that idea? Factoring by grouping? So let's go ahead and group the first 2 and the last 2. And I'm going to go ahead and put it on this side. So x cubed plus x squared minus 16x minus 16. So let's group the first two and the last two. So in the first group, I could factor out an x squared, and you get x squared times x plus 1. Okay, x times x squared times x is x cubed, x squared times 1 is x squared. In the second group, remember, you're going to factor out that negative part here, that negative GCF, which will be a negative 16. And if you do this correctly, if it is factored by grouping, those two in parentheses better be the same. Negative 16 times x is a negative 16x, and a negative 16 times a positive 1 is a negative 16. So notice x plus 1s are in parentheses, so we factor that out. And when I factor that out, I get the x plus 1 factor out, I get x squared, and then minus 16. Now notice, though, I can factor this further, so let's go ahead and do that. So I get x plus 1 times x minus 4 times x plus 4. All right, so I could have factored that further. Okay, so that is going to go here. So I have x plus 1 times x minus 4 times x plus 4 is greater than or equal to 0. And notice that this now, see this right here? That kind of looks like the first problem we had, right? It looks like this. All right, and so we just find the zeros now. So it's in factored form. So let's find the zeros. So the zeros are, remember, sometimes we call them critical numbers. Or you could call them boundary points. All right, so the zeros are, also remember there's an equal sign here, so that's going to be important. All right, so the zeros are, you're going to set each of those factors equal to 0. So when I set x plus 1 equals 0, I get x to be negative 1. So there's one of my zeros. When I set the next one equal to 0, x minus 4 equals 0, I get x to be 4. So there's the other critical number, or the other 0. When I set the last factor equal to 0, I get x to be negative 4. So those are your 3 zeros. Once you find your zeros, you put them on the number line. Make sure you put them in order. And you have negative 4 listed first, then negative 1, and then 4. And then now it's just a matter of you determining your test points. So notice that these zeros divide the number line into 4 intervals. Negative infinity to negative 4, negative 4 to negative 1, negative 1 to 4, 4 to infinity. All right, now remember those are zeros, right? So if you substitute, you get 0, 0, and 0. So when x is negative 4, this is 0. When x is negative 1, this is 0. When x is 4, this is 0. All right, and notice the equal sign, so you are going to use brackets with them. Bracket, bracket, bracket. If there were no equal sign, you would put parentheses. Okay, now let's pick the test points. So give me a test point between negative infinity and negative 4. Remember, it's always easiest to use an integer. So let's say negative 6. From negative 4 to negative 1, there aren't that many integers. There's an infinite number of numbers, but we want to try to use integers if possible. So the only integers that are available for you to use would be negative 3 and negative 2. Let's use negative 2. Over here, I can use 0. 0's in there. It's always the easiest to use. And then from 4 to infinity, let's say 5. All right, so those are my 4 test points. All right, now remember what you do. You go and you substitute those test points into, and I always go back to the factor part rather than here. You can go back to the original. It's just a little bit more work. So let me kind of show you how you would do that. So I'm not going to have enough room here, so I'm going to have to use this other sheet of paper to kind of do all this work that I want to show you. So our test point is x equal negative 6, right? So if you use the factored part, that's easy. You're going to say negative 6 plus 1 times negative 6 minus 4 times negative 6 plus 4, right? Well, negative 6 plus 1, that's negative. That's a negative what, 5? Negative 6 and negative 4 is a negative 10, that's negative. And negative 6 plus 4 is a negative 2, that's negative. A negative times a negative times a negative is a negative. A negative times a negative is a positive, positive times a negative is a negative. So no matter which test point I use in this interval, that's going to make this right here or this, they're both equivalent, It's going to make that negative. Now, before I go on, I forgot to indicate what I want this to be. So my solutions for the variable x are the ones that are going to make this left-hand side greater than 0 means positive. So positive r, and there's an equal sign, so you're going to say r0. So that's why for the 0 we put brackets here. All right, so if I want this to be positive, then is this interval going to be a solution? No. Because no matter what real number I use that's in this interval, it's going to make this side negative and not positive. But I wanted to tell you, if you went back to the original, you're going to have to use your calculator. You have to be careful because you have to use parentheses. So this is what you would have to say. First of all, you would have to write, if your test point's -6, you would say -6 cubed, okay, plus -6 in parentheses squared. See, they're all in parentheses because it's negative, minus 16 times -6, and then minus 16. So on your calculator, you're going to do this. Parentheses, -6, close the parentheses, cubed, plus, parentheses, -6, close the parentheses, squared, minus 16 times, in parentheses, -6, and then minus 16 equals -100. So that's negative. So negative, negative. It is quicker if you use the factored part, but you got to make sure that you factored it correctly, right? All right. Okay, so that's what you've had to do. You would need to use your calculator with this part here. Okay, now let's go ahead and do the next one, test point -2. So if x is -2 as my test point, and I'm going to just go ahead and just use the factored part. If you want to use the original, use your calculator. You got to be careful. So if x is -2, I get -2 plus 1, -2 minus 4, -2 plus 4. So wherever I saw the variable x, I substituted -2. Well, -2 plus 1 is a negative number. Okay, it doesn't matter whether it's negative, in this case -1, but that doesn't matter. I just need to know the sign. What is the sign of that number? -2 and a -4 is a negative number. That's -6. -2 plus 4 is a positive number. It's actually +2. A negative times a negative times a positive is a positive. So what I found is that in this interval, in that second interval, any real number that's between -4 and 1, -4 and 1, will make this left side positive. And that is something I want. So I'm going to check it off. So there's one of my solutions right there. Then I go to 0. If x is 0, do the same thing. If x is 0, I have 0 plus 1, 0 minus 4, that's a 1 there, and then 0 plus 4. So 0 plus 1 is positive, 0 minus 4 is negative, 0 plus 4 is positive. A positive times a negative is a negative times a positive is a negative. So that's negative. So what I found is that any real number between -1 and 4, in that interval, will make this left side negative, and I want positive. So that interval right here is not going to be a solution. And then finally, we go to the last interval. We're going to use the test point 5. If x is 5, let's see what we get. If x is 5, do the same thing. You're going to say 5 plus 1, 5 minus 4, 5 plus 4, right? Well, 5 plus 1 is positive. 5 minus 4 is positive. 5 plus 4 is positive. Positive times a positive times a positive is a positive. And if you had used this right here, you better get a positive number, right? So watch. If you use the original, you would say 5 cubed plus 5 squared minus 16 times 5 minus 16. Now, I put in parentheses, but since 5 is positive, it wasn't needed. So notice when I put that in, I'm just going to say 5 cubed. I'm not putting parentheses. 5 cubed plus 5 squared, right? Minus 16 times 5 minus 16 equal positive 54. So it'll be 54, which is positive. All right. So what that means is that any real number from 4 to infinity will make this left side a positive number, and that's something I want because I want it greater than 0. So that is an interval of my solution. And so therefore your solution will be, remember the zeros are included because of the equal sign. So your zeros are going to be bracket, -4 to, so from here to here, that interval, to -1 bracket, union, and then bracket 4 to infinity with parentheses. Now remember, with infinity, negative infinity, you must always use parentheses. All right, so there's your solution. That's all you do. It is not a very difficult process. All right? Let's look at number 4. Let's do one more because of the time. Number 4. So number 4, I have x cubed plus x squared is less than or equal to 4x plus 4. All right, so what's the first thing you need to do? Well, the first thing you need to do is make sure that this is in standard form. So you have to have 0 on that other side, and you don't. So let's bring these two terms to the left side. So when I do that, I get x cubed plus x squared minus 4x minus 4 is less than or equal to 0. All right, 4 terms, right? 4 terms. We're going to try grouping. So let's go ahead and write this over. X cubed plus x squared minus 4x minus 4. So let's group the first two and the last two. In the first group, I could factor out an x squared. I'm left with x squared times what? X plus 1 minus, and then that GCF is 1. So notice I put a 1 there. I'm sorry, 4, excuse me. That GCF is 4, so I put minus 4 times x. All right, now remember what you have in parentheses here better be the same as this if this is factorable by grouping. -4 times x, -4x, -4 times a positive 1 is a -4. And so those are the same, so I'm going to factor that out, the x plus 1s. When I factor that x plus 1 out, I get x squared and then minus 4. But I want you to notice that x squared minus 4 is factorable further, so go ahead and do that. It helps. So x plus 1 times x plus 2 times x minus 2. And so this right here is going to be the product of these three factors. So x plus 1, x plus 2, x minus 2 is less than or equal to 0. All right, so now we're going to find the zeros. So the zeros are, we're going to set each of those factors equal to 0. X plus 1 equals 0, so x is -1. The next one, x plus 2 equals 0, so x equals -2. Next one, x minus 2 equals 0, so x equals 2. So those are your zeros. So we got to put those zeros on the number line, and we're almost done. Put them in order though. -2 comes first, then -1, and then 2. All right, so notice that these are zeros. So what that means is that it makes this inequality. I'm going now. When talking about zeros, you got to make sure that you're always referring to the part where you see a 0. Don't use this one. All right. So this one. So when I say that these are zeros right here, that means -2 makes this 0. -2 makes this product 0. That's what that means. Okay, because you see a 0 there. It doesn't mean that -2 makes this 0. That's not true, because that's not a 0 here. All right, so you got to be careful. You got to be careful. All right, so these are zeros, and when I look at this product here, I do want this left side. Remember, you got to use the one with the 0 in it. That's why step 1 says make sure you see a 0. So you want this left side here to be less than 0, meaning negative. So negative r equal to 0. So since there's an equal to 0 here, I'm going to use brackets. I'm going to use bracket, and I'm going to use bracket, because those are going to be solutions. So those are solutions as well because of the equal to 0. Okay, but now I got to determine whether these intervals, which of those intervals are solutions. So that's the next step. So I've got to pick a test point. So from -infinity to -2, let's try -5. now, remember, it's always easiest to use integers, but sometimes you cannot. So let's pick a nice number between -2 and -1. There is no integer, so we're going to have to say -1.5. Between -1 and 2, the only two integers are 0 and 1, so let's just say 0. And then from 2 to infinity, let's say 3. All right. So now we're going to determine whether this test point, when we substitute it, is positive or negative. So I'm going to do the work in another sheet of paper, just like I've been doing with the others. And so let's do this. So test point, x equal -5. So when x is -5, let's just go back to the completely factored part here. So when x is -5, we get -5 plus 1 times -5 plus 2 times -5 minus 2. -5 plus 1 is negative. -5 plus 2 is negative. -5 and -2 is negative. So a negative times a negative is a positive times a negative is a negative. So what that means is that when I choose any real number from -50 to -2 and I substitute into this left side or this left side, that number is going to make that left side and that left side negative, which is something I want. Less than 0 is something I want. All right, so I'm going to check it off. So there's going to be a solution set right there. All right, now make sure, I just want to say this, make sure you go back to this one and not this one. All right, because this is not 0 over here. You got to use the one where it's 0. That's why you always reference to 0. Less than 0 is negative, greater than 0 is positive. -1.5. So x is -1.5. This is what we get. When x is -1.5, go back to the factored part. I have -1.5 plus 1, -1.5 plus 2, -1.5 minus 2. And so when you put that in your you actually don't need a calculator for this. You can determine whether it's negative or positive. -1.5 plus 1 is a negative number. That's -1/2. -1.5 plus 2 is a positive number. That's +1/2. -1.5 and -2 is a -3.5, so that's negative. So a negative times a positive times a negative is a positive. So in that interval right here, in that interval from -2 to -1, all of these real numbers will make this left side and this left side positive, but that's not what I want. I want it to be negative or 0. So I can't use it. Now I just want to say, if you went back to this one, now don't go back to this one, go back to this one, because you want to determine if it's negative or positive. If you go back to this one, now use your calculator carefully. Since x is negative, you are going to need parentheses. So -1.5 cubed plus -1.5 squared minus 4 times -1.5 minus 4. And on your calculator, hopefully we'll get a positive number, because that's what we said it was supposed to be. So in parentheses, -1.5 cubed plus, in parentheses, oops, I forgot the negative, in parentheses, -1.5 squared, okay, minus 4 times, in parentheses, -1.5, close the parentheses, and then minus 4 equal positive 0.875. So 0.875, which is positive. Okay, and that's what we wanted it to be, a positive number. The next one is 0. So the next test point is 0, x equals 0. So when x is 0, here's what we get. We get 0 plus 1, 0 plus 2, 0 minus 2. 0 plus 1 is positive, 0 plus 2 is positive, 0 minus 2 is negative. It's a -2. A positive times a negative is a negative, right? That's negative. So no matter what real number I use between -1 and 2, no matter what real number, there's an infinite number of real numbers here, is going to make this left side and this left side negative, which is something I want. Less than 0 is negative. So I'm going to use this. So there's another solution set right here. And then finally, let's use 3. Check 3 if x is 3. Now again, don't Don't make the mistake and start assuming that they're going to alternate, because the problems we have now don't, but you could have a problem, which it does, so you got to be careful. And that's going to be an example in the next lesson. X is 3. Test point x is 3. We're going to substitute x equal 3 into x here. So I get 3 plus 1, 3 plus 2, 3 minus 2. And so when I look at the sign of these factors, 3 plus 1 is positive, 3 plus 2 is positive, 3 minus 2 is positive. And a positive times a positive times a positive is a positive. So what that means is that this interval from 2 to infinity, if I choose any real number in that interval, is going to make this left side or this left side positive, but I want it to be negative. So I can't use that one. So the only solutions are these two intervals. So your solution. Now, remember, there was an equal sign, so you need brackets. So your solutions are from negative infinity to negative 2 with a bracket. And then the next one is this interval. And then from union, and then from bracket negative 1 to 2 with a bracket. And there's your solution. So any real number that's in this interval will make this inequality a true statement, this inequality a true statement, this inequality a true statement. Okay? So that's it. So there's your solution. So these are 4 examples. So these are 4 examples on solving, let me go back to the original, on solving higher order polynomial inequalities. And all of these are factorable. Just make sure that you're following the steps correctly. Okay? You're following this. When I say the steps, I mean this procedure right here. Okay, so that is the end of this lesson.